I'm Carrie Laboski, a soil fertility and nutrient management specialist at University of Wisconsin. Today I'm going to talk about fundamental soil fertility strategies for success. These strategies can be used in any year, but they're especially important in a low margin year. When we think about soil fertility, it's a really significant crop input. It can be anywhere from 5 to 20% of the cost of total crop production. If we think about lime, that can be maybe up to 5% of the total cost. So that's a large portion of costs. Now, we know that poor fertility or nutrient management practices will reduce profitability. So it's really important to know how to spend your money and do it wisely. So with that, we need to think about soil testing. That's the best way to make our initial basis of soil fertility, and it's really a good investment. When we think about the cost of soil testing, it might be anywhere from 40 cents to $1 per acre per year, and that's roughly the cost of a few pounds of fertilizer. So not very much considering the return on that investment that you'll get. Now, when you are using soil tests, you want to use recent tests. That means that they're no more than 4 years old. The more recent, the better. If it's a 10-year-old soil test, it's probably too old to be useful. And also, when you're soil sampling or having others sample for you, you want to make sure that they do a good job and that those soil samples adequately represent your field or portions of field so that you can get good nutrient recommendations. So we're going to move into talking a little bit about lime. Liming and soil pH, they are the cornerstone of a profitable soil fertility program. If you do not have your soil pH right, you're often going to get low production. And here's a few photos showing two different fields in different parts of Wisconsin actually, but they have the same problem. They have pockets of very low pH. In one case, the pH here is 4.7 in that dead area, and over here it's 3.8, so extremely low pH. One thing I'd also like to point out with these is how soil sampling can be used to find them. The field on the left, initially, there's more than one of these dead areas in the field. They weren't found in soil testing that had been done the previous fall because it was grid soil sampled and the grid size was too large. So it missed all this variability with these small areas of low pH. Now this other field, when we look at this, we can see there's the obvious area where there's no crop growing, but we could also see poor production in several other parts of the field. And so here a good soil sampling strategy would be necessary to make sure we find all those and correct the pH problem. Now the chart here is really just to remind you of how big an effect that soil pH can have on our crop yield. And if we look at corn here, which is the blue, we can see compared to soybean and alfalfa, we can see that corn, it holds yield longer, so to speak, at lower pH. And it isn't until we start getting below pH 6 that we'll start losing corn yield. Whereas with alfalfa and soybean, we'll start losing yield when the pHs are above 6. And on the right here, this table is just to remind you what our target pH is for several of our crops. For our legume crops, it is over 6.8, it's higher. Alfalfa especially is at 6.8, and for our grass crops, corn and wheat, we're at pHs of 6.0. Now the key here with why soil pH is so important is soil pH affects nutrient availability and also soil microbes, which in turn affect nutrient availability. So really a key function, and that's why it's the cornerstone of our soil fertility program. Now I often get asked questions about lime, and one of the questions I am asked is, what if I need lime but I can't afford it? Well, the quick response is don't plant a legume this year. The pH will probably be too low and you'll get low productivity. The other thing is to keep in mind is that you may still need to make the investment of lime because it does take 3 or more years for lime to be fully effective and react with the soil. You can think of it as a medium-term investment. Therefore, you might really need to think about ways to make sure that you can get lime applied if your soil pH is low to ensure that you can keep your crop rotation going in future years. Yet another question I'm asked about lime is, something along the lines of, my soil test report recommends 3 tons per acre of ag lime, which is going to cost me about $105 per acre, say. Can I band apply 500 pounds per acre of Pell lime, that's only going to cost me $50, and have the same effect? The answer is no, you can't do that. To be as effective as ag lime, Pell lime must be applied at the same rate as ag lime. And that's based on some research we've conducted at the Arlington Ag Research Station. So, a pound of lime is a pound of lime. You can't shortchange yourself there. Now, moving on and thinking about potassium and phosphorus a little bit, these two are very important nutrients, and we're often really concerned about phosphorus and we forget about potassium. But I think we should really reconsider that. And so what I'm going to show you here are some results from a study that I've been conducting at our Arlington Ag Research Station over a number of years, looking at both phosphorus and potassium response in corn and soybean. And so here we have a response to potassium. I should state that in this study, at every rate of K applied, and here's 0 to 160 pounds of K, the same rate of K is applied to the same plots every year. And at each rate of K, we have plots of phosphorus ranging from 0 to 90 pounds of phosphate. And so here again, we're just going to look at the response to potassium in corn and soybeans. The initial soil test levels in these fields was 58 parts per million for this left field and 49 parts per million for this one field on the right when we started the study. And I would like to point out we have all of our different yields from 2011 to 2016. And the 2012 growing season, as many of you may remember, there was a very large drought. We saw very low yields in both corn, soybean and corn here, but we did see significant increases to potassium still. Now in 2016, we had very good yields for both corn and soybean and large responses. Now after our numerous years of cropping here on this site, if we look at our initial soil test K levels in the spring of 2016, before we put on any more fertilizer, we were looking at 61 parts per million soil test K on this plot here with the 0, and an average here of 56 parts per million. So you can see that soil test levels changed very little over that time. Even though we hadn't put any more K on those plots, they hadn't moved around a lot. We also know for both corn and soybean that 80 to 120 pounds per acre annually was about the rates that maximize yield. And so you can see that here in corn, 80 to 120 pounds, somewhere in here is about where the yield is flattening off. And same thing for beans. We did see one here in 2013 for soybean where only 40 pounds was necessary to maximize yield. I'd like to point out that potassium has a huge effect on yield for both corn and beans. And if we look at our yield where no K was applied and compare that to our plateau here where the yield level's off, we can see that on average over the years, not counting 2012, there was a 30 bushel yield increase with a K application for soybean. And if we look at corn, we see much larger yield increases. And on average, over all the years, again, with the exception of 2012, we see 200 bushel yield increase in corn. And if we look at 2016 in particular, which was very high yields, 269 bushels were the average plot yields up here, compared to 34 bushels down here, which resulted in a 235 bushel yield increase. And so these are tremendous yield increases from potassium. And to give you some perspective, at this research station we have an adjacent field, really only about 100 yards away, where we have P and K supplied, but we have with and without nitrogen on this corn. And the yield in 2016 was 215 bushels, so it was right here. So it was pretty much the same yield as we got here at that 40-pound K rate. So if we think about no nitrogen but adequate other nutrients is a yield of say 200 bushels compared to 34 when we're lacking K. So clearly, our soil is doing a good job of supplying nitrogen, and K can be extremely limiting. Now in years that aren't like 2016, in some of these other years here shown, we would be getting anywhere from maybe 120 up to 160 bushel of corn with no nitrogen. So again, that's just not the one particular year, but all years. This really highlights how much low K can affect your yield. Now, if we look at phosphorus response, I don't have any slides or graphs set up for this because it's not a whole lot going on there. Now, our initial soil test P levels were 1 and 8 parts per million, so both very low soil tests. And if we look at corn first, we did see a response to phosphorus in 2014 when soil test K levels were over 65 parts per million. In 2015, we also saw a response to phosphorus at any K application rate. And for that, we were able to find an economic optimum P rate of 60 pounds per acre. But the other 3 years when we had corn planted, there was no response to phosphorus, none. And we started with these very low tests. Now, soybean, we had in 2016 a nice response to phosphorus, but only where soil test K was over 75 parts per million. And there it was about a 5 bushel per acre response. Now, in 2011 to 2015, there was no response to P at all, even if soil test K was greater than 75 parts per million, like we saw. So there's clearly some weather interactions with that. So overall, the response to P doesn't happen very often, and the magnitude of the yield increase from P is much, much smaller than K. So when we think about our nutrients, what does that tell us? Well, it tells us if we have to prioritize and adjust P and K applications, that if both P and K are low and you can't afford to apply both nutrients, you really need to focus on K and put your money there. That's where you're going to have your biggest bang for your buck, so to speak. Now, if you can afford some of both nutrients, but you need to think about adjusting rates, here's a little bit of guidance on how to do that. If your soil test is optimum, I would stick with the recommended rates. Our rates are about equal to crop removal when we're testing in the optimum category. If your soils are testing high or very high in P and K, I would apply the recommended rate or cut back, apply a little bit less. This does mean your soil test will decline a little more quickly, but if you're only doing this for a year or two, you shouldn't see large changes or decreases, that is, in your soil test levels. And if your soils are testing excessively high, generally there's no recommendation for nutrients anyway, so follow that. Now, the key here is on the low and very low testing soils. This is where you can cut back, and you could apply the rate that would be recommended if the soil had tested optimum. So what's happening here is we're not going to be building soil test levels, but we're going to be just trying to supply just what's needed for the crop itself. And so that's a little bit of guidance on how to adjust some of your recommendations, or I should say your application rates, if you need to cut back on fertilizer expenses. Now let's talk about starter fertilizer a little bit. It's a great way to apply nutrients if they're needed. But what if you don't need nutrients? How useful is starter fertilizer on high testing soils? Well, that's what I want to talk a little bit about. I want to look at some data that was collected in the mid-90s. There was 100 sites throughout Wisconsin with 2x2 starter. It was dry starter. The soils had a range of soil test P and K levels, but they mostly had excessively high P and K. And the idea behind this was to find out, if we test, very high, excessively high in P and K, is starter necessary at all? And so one of the things we're going to look at this data is we're going to put it in the context of today. And so let's say today we're going to apply 100 pounds per acre of 923.30, and that might come out to cost about $17.80 per acre based on some of the pricing we have today. Well, if corn is $3.90 per bushel, that means we're going to need to have a yield increase due to starter fertilizer of 4.5 bushels per acre. Okay, so can we get that? And so when we look at that 100 site data, what I did was I took all the data and I just looked at the yield increase. I said I'm not going to worry about whether it was a statistically significant yield increase, just if yield increased at all. And I wasn't going to worry about if some soils had a high soil test P and K or others had excessively high. And I also looked at it lumping all of the planting dates because you can imagine with 100 sites throughout the state, there was a little bit of a range in planting date. And when looking at it like that, big picture, we can see that if we're trying to get at least 4.5 bushel per acre yield increase, that was going to happen on less than 40% of the time in that data set. So that data set showed a 4 bushel per acre yield increase 49% of the time. So that's less than 50%. So that means flipping a coin would be a better bet than perhaps applying starter fertilizer in this situation. Now, another thing to keep in mind that when the study was originally conducted, it was found that there was some interactions between planting date and relative maturity of the hybrid with regard to response to starter fertilizer. And so if you want to have a better than 50% probability of having a positive economic return on your starter fertilizer is, if you have late planted corn, so late May, and you're still using a relative maturity hybrid that had greater than 100 days. And so what's happening here is it seems a little counterintuitive to people because everyone always says it's a cold, wet soil where you see a response to starter fertilizer, but here where soils are already testing high, it's late planting and using longer relative maturities than what you should be for that late in the growing season. Starter fertilizer hastens maturity. So when you're planting late and have a longer day relative maturity, you need to move things along, and that's what starter fertilizer does and can help you there. Now, another starter fertilizer study we had more recently was looking at liquid starters and the nutrient composition, and that was nitrogen, phosphorus, potassium, sulfur, and micros, along with placement of the nutrients, or the starter, whether it was 2x2 or a pop-up. And we found that, and these were on all optimum to excessively high P and K testing soils. And there's just 2 locations at Lancaster and Arlington over a few years. And we found that nutrient composition and placement had minimal and inconsistent effects on grain and silage yield, as well as early season biomass accumulation. So sometimes you see that starter effect, the crop looks a little bit bigger early in the season, maybe up to V5, but even there we didn't see much. Another factor of this study was looking at other management practices that growers might try to help push yields, and they included having higher than recommended nitrogen fertilizer rates, higher seeding rates, and foliar fungicide application applied at VT. And when those practices were used, we also found that starter fertilizer wasn't any more useful or not useful. So again, when we start thinking about high, very high, excessively high P and K testing soils, starter fertilizer may not have the best payback in all situations, especially if we're looking at a low margin year. Now, moving into nitrogen, I want to talk about this for a little bit because it's a pretty big cost, especially for corn production. And so to start off, I just want to show you some data, and this is from trials that we've conducted across the state. Some of them are small plots at some of our ag research stations. Some of them are larger field studies in grower fields that we've conducted with some of our county extension colleagues. Now here we're looking at the yield obtained at the economic optimum N rate and versus the nitrogen applied to get that yield. And you see a lot of nothing here. And we'll just kind of point out what we've got going for our points. We've got corn following corn, which is CC, corn following soybean, whether they're high yield potential soils or medium yield potential soils. And then we also have on here as well our irrigated sandy and non-irrigated sandy soils. And overall, there's just no relationship between the amount of N applied and the yield obtained. And that's really important to keep that in mind, because I know there's a thought that, if I'm getting high yields, I really need a lot more nitrogen, and it doesn't really pan out that way. And so I want to show some other aspects from that database. And here we have the percentage of total yield at the economic optimum N rate. And we have the brown is representing the percentage of total yield that's obtained from the soil, and the blue is the percentage total yield obtained from fertilizer. And so if we look at our corn following corn on our medium and fine textured soils, about 60% of our total yield is coming from soil. For corn following soybean, we have 73 to 83% of our total yield is coming from soil. And then we get into our irrigated sandy soils. We've got, 50% or less, in some cases a little bit more, is coming from soil. So what this means, if we translate this into bushels per acre, on our loamy and finer soils, fertilizer is providing about 60 to 90 bushels of our yield for corn after corn, and 20 to 60 bushels of yield for corn after soybean. And on sandy soils, really water is much more limiting. And so that's why the effect, how much yield the soil supplies varies more and is a little bit lower, is because water is more limiting. What this ultimately says is our soils here in Wisconsin, most of them, especially our medium and fine textured soils, really are nitrogen mineralization powerhouses. We can provide a lot of yield to our crop. And so we don't necessarily need to supply as much nitrogen as some people think. I'm not saying we don't need to supply any, but we need to think about that and how much yield we're actually going after with that nitrogen fertilizer. And so that leads me to showing a nice yield response curve to nitrogen fertilizer applied. So here we have our N application rate on the bottom versus our corn yield, and we can see our yield levels increasing nicely, and then they taper off. The point right here, that represents the economic optimum nitrogen rate. Now I also have shown on here our return to nitrogen, and those are the green bars, and that's showing that we made $67 per acre on this first 40-pound increment of nitrogen. The next 40-pound increment, we only made $60, and here at the next increment, only $46. You can see it going down. Then we start losing money. So this is showing us the law of diminishing returns, and kind of lines up very nicely with our economic optimum N rate. I do want to point out, I also have drawn on here in the yellow bars, that's our nitrogen recovery in the whole plant above ground at physiological maturity. And you can see that as we apply more nitrogen, the percent of the nitrogen applied that we can recover continues to go down. And so what that means is if we've applied nitrogen and we're not recovering it, it means it's left it out in the environment. And the probability that it's there the next year for us to use is pretty low. So that represents lost profitability here when we're applying nutrient but not recovering it. And so with that, we'll just kind of talk very briefly about what our actual nitrogen guidelines are for corn. We do use a maximum return to nitrogen philosophy. And so we have those, all this data that we've collected, and we look at a couple things. First, the nitrogen to corn price ratio. I'm not going to go into a lot of detail, but we have 4 different categories here. And today, this orange category of 0.1 is reasonable for most everyone. And what 0.1 means is that, to give an example, it would be like having a 30-cent nitrogen and $3 corn, or 40-cent nitrogen and $4 corn. We also look at our types of soil we have, whether they're loaming soils or sandy soils, and then we get into previous crop situations. I do want to point out that if we're looking at any particular soil yield potential and previous crops, say here for corn following corn on a high yield potential soil, our MRTN rate or recommended rate is 165 pounds per acre. The range of N rates here, right here, from 155 to 180, what that represents is, based on our data set, all those N rates would provide profitability within $1 per acre of the MRTN. And so $1 per acre, that's a pretty narrow margin. So you've got a lot of a window to shoot for in getting a nitrogen application rate that will be profitable for you. And I'm not going to go into any more detail on this. We can do that at some other time. I just want to point out that as you do look at our recommendations, that you note that there's a lot of footnotes, and it's really important to read them because there are some important details there. Now I want to spend a little time talking about the effect of nitrogen timing on corn yield. And the reason for doing this is there's been a lot of questions recently about timing of application and especially late applications, pre-tassel. So here we have a study was conducted over several years at Lancaster and Marshfield. And I'm not going to show you all the data, we're just showing one particular year. And talk about the different timings. So we have the blue dot is pre-plant, all the N was pre-plant. The red is all nitrogen side dress. The green is 40 pounds applied at pre-plant and the remainder at side dress. The purple is a variety of rates applied at pre-plant and then an extra 40 pounds applied late. And here late is 7 to 10 days prior to tasseling. And then this final triple split application is 40 pounds pre-plant, a variety of rates side dress, and 40 pounds late. And so if we start here looking at Lancaster, we're on a well-drained soil at this site. And there's no significant difference between these N application timings when we get up into this area of the curve where our optimum N rate occurs. Now we do have some difference between N application timings where if we're waiting to apply N late, we have some lower yields, but this is below our economic optimum N rate. So when we're at our economic optimum N rate, no difference between timings. And that pre-tassel timing didn't provide any sort of yield bump. So if we look at that, the purple or this blue star, those yields are the same when we look at the total N application rates. And that's important because there are a number of people suggesting that these late applications can provide a yield bump, and we're just not seeing that. And this is, again, 1 year's data, but there are two other years as well that support this same conclusion. Now, if we go over to Marshfield here, this soil is a little bit different. It's a somewhat poorly drained soil, and we can see a lot of differences and things going on in this graph. So one of the first things I want to point out is here we have the pre-plant application. It's our lowest yields, and it's showing that we've lost nitrogen, especially when we compared that to side dress. That red triangle, here's a red triangle underneath there and then up here. And we see that if we applied all of the nitrogen side dress, that was a great application timing. We had much greater yields with very little nitrogen. And so again, comparing the side dress to the pre-plant, it really shows how much nitrogen was lost in that early season time. One other thing that we can, conclusion we can draw from this data set is about late application timings. So if we have an 80-pound rate that we applied pre-plant, and we get a lot of rain, and then we decide, well, we maybe want to try to do a rescue treatment and come back and apply 40 pounds prior to tasseling, that would mean that that blue treatment became this purple treatment at the 120-pound rate because we applied the 40 pounds late. We can see we had a nice yield increase. It did pretty much the same as if we would have side dressed the whole thing. And we can see that it happens at these other rates as well. So the key here is when we've had early season nitrogen loss, we can come back with a pre-tassel application and help rescue that crop. And that's an important thing. The pre-tassel application, probably, we don't want to plan on that every year because it didn't necessarily do a better job. And I do want to point out that the side dressing application, on this somewhat poorly drained soil was, our best option. We had the greatest yield with the least amount of nitrogen applied. Now, another component of good nitrogen management that I think we often forget is thinking about the interactions with other management practices. For example, weed control. So here's a graph from a study that we conducted at Arlington a few years ago, where we look at our corn yield response to nitrogen, but under the influence of different levels of weed control. The green represents where weeds were controlled pre-emergent. The blue, weeds were controlled when they were 4 inches tall. So both of these, the blue and the green, would represent recommended weed control timings. If we look at the yellow line here, that's where weeds were not controlled until they were 12 inches tall, so it's getting late. This doesn't look good. We're losing yield. We can compensate, but we need a lot of nitrogen to do that. And then the red is where we just have no weed control at all, which is clearly not desirable. And so just to point out what our economic optimum N rates were, when we're looking at the pre-emergent or the 4-inch tall weed control timings, we had an economic optimum N rate which was within 33 pounds per acre of each other. So that's good, and we can see that we never did hit a plateau yield level when we were waiting to apply or waiting to do weed control or not doing it at all. So again, you just really can't afford poor weed control. Stay on top of the weed control, and you'll have a better nitrogen use efficiency. Now that leads me to talk a little bit about wheat. I just want to point out that we do use a maximum return to nitrogen philosophy in our wheat nitrogen recommendations. There are a little bit of nuances to it because it is a different crop than corn, but it is set up similarly in that we have our nitrogen to wheat price ratio, and we've got differences between soil groups and also previous crops. One important point about wheat that we found recent in some of the research on the eastern side of the state is that applying nitrogen at green up typically is going to provide a yield advantage compared to applying at the Zaduk's 30 or Feeks 5 growth stage. So early typically is a little bit better. So that's an important thing to keep in mind. Now, moving along to sulfur, something a little different here. You should consider using sulfur for corn and alfalfa if you've had sulfur deficiencies in the past, or if you have low organic matter soils, sandy soils. If you haven't seen deficiencies, or you're on silt loam soils with 2% or better organic matter, if you have a manure all the time, you might not need much sulfur. Now, if you do need sulfur, 15 to 25 pounds per acre in a sulfate form can be really profitable. This can be almost a 2-ton yield increase in alfalfa. And so that's really big and highly profitable. Again, but it's where you need it. If you don't need it, don't put it on. Now, micronutrients. These are always interesting. Folks are often very concerned about micronutrients, but the reality is we don't see very many deficiencies here in Wisconsin. I'm not saying we don't have any. We do have some, but we don't have as broad a problem as what most people think we do. And so when we think about micronutrients, it's really important to know crop sensitivity to a given micronutrient and also the conditions that produce low availability of that micronutrient. And so if we start with zinc, corn is the crop that we grow here in Wisconsin that has the greatest demand for zinc. Where we're going to see problems with low availability are going to be on sands, loamy sand soils. Organic soils can be problematic, and severely eroded soils. And so sometimes it might just be those eroded knolls. So it may not be like a whole field, it might just be a little pocket because you had some erosion there. And also high pH soils can be problematic for zinc. Manganese is also a micronutrient of concern, but it's primarily for soybean and wheat. They have the greatest relative need. We typically are going to see manganese deficiencies on soils that have pHs greater than 6.8, especially if they're calcareous, and also if soil organic matter levels are high, over 6%. So if you have a soil that has maybe a 6.7 pH and an organic matter level of 3.5%, you're probably not going to see much problem with manganese. Now, boron is another nutrient that recently a lot of people have had some concern about, but realistically we don't see a lot of issues with it here in Wisconsin. Alfalfa is the crop that has the greatest need for it and is most sensitive, and we typically see more response to boron in an alfalfa on sandy soils because sandy soils just don't hold as much boron. So these are 3 key micronutrients in some of our main crops of where we need to be concerned about them. But overall, outside of these situations, probably don't need to worry too much about them. Now, manure is an excellent nutrient source, and if you're going to use manure like a fertilizer, you should be treating it like a fertilizer. Get the most you can out of it. So that means taking samples of your manure, testing it for nutrient composition, knowing how much you spread, where you spread it, so you can really do a good job of taking your nutrient credits. And if you can do a good job of spreading your manure, and taking nutrient credits, that means you can reduce your fertilizer bill. And also with reducing fertilizer bills, think about your rotations and plan your rotations to maximize nitrogen credits from forage legumes. And I just want to point out that alfalfa, we can have a range of nitrogen credits to first-year corn following alfalfa. It might be as little as 40 pounds per acre in some situations, but can be as much as 190 pounds per acre. That means that you can apply no nitrogen for corn following alfalfa, or maybe you need to apply some, but largely it can provide a lot of nitrogen. And so think about planning your rotations to provide nitrogen for your corn crop, and so you don't have to spend as much money. And last but not least, it is important to practice for our nutrient stewardship. What does this mean? It means applying the right source of nutrients at the right rate, in the right place, at the right time. If you can get your nutrient management right, it's going to improve your profitability, and it's also going to improve environmental stewardship. And that's all I have for today. If you'd like more information about nitrogen rates, a good source for that is your county extension office. You can get a hold of me as well, but also an extension publication, 820-809, Nutrient Application Guidelines in Field, Vegetable, and Fruit Crops in Wisconsin. If you just Google that, UWEX 820-809, that'll be the first thing that comes up, and you'll find a website where you can download it for free, and you can get more information about rates there. Thanks, and have a great day.